Okay, so we are curve sketching here.
Yay.
Okay, this is taking what we know about first derivative, what we know about second derivative, and putting it all together. Okay, how does it all relate to the original graph? Okay, so I'm not going to read the paragraph. You guys can read it. I don't. Example 1. Complete the table below by sketching general shape of the curve when each condition is met. We've talked about this a little bit at times. But so basically, what's the graph going to look like when first derivative is greater than 0 and second derivative is greater than 0? So what's first derivative greater than 0 mean? What's second derivative greater than 0 mean? So what does a piece of graph look like that's increasing and concave up? Okay. You can think of it like an exponential graph, something like that, right? It's always increasing and going up. What if we change it to first derivative less than 0? Flip it, as in something like that. Wait.
I was like, that's not concave up.
That wasn't decreasing either. My goodness.
Huh? Oh,
I flipped it the wrong way the first time. Is this right? Decreasing.
it looks right.
And concave up. Yes. Wait, let me check. Okay. It agrees with my answer key.
Mrs. Sargent, I had the right thing too, and you threw me off.
Sorry.
I followed you.
Are you writing it down?
Yes.
Are you realizing today, I'm obviously not quite all there today. You might not want to follow me right away. Okay. Try, dare even try. Second derivative less than 0. Now we're looking for the concave down options. So take your options from above and make them concave down. So, you know, the one I just drew a moment ago, I'm ready for it now. There's your increasing, and then the curvature is facing down, right? And then decreasing and concave down. Have you thought about it? Something like that. I'm good, Maddie. Maddie's giving me this look like, are you sure? Obviously, I'm not very sure today, but... Okay. Are you guys better on that than I am, maybe? Okay. Example 2. And I think I'm going to blow this up. I don't have 2 pages per, Probably going to blow this up so I have more room to work with it. Sketch a possible graph of the function g of x satisfying the following conditions. Okay. This is like the challenge here. I'm going to blow this up so I make it readable for you guys, room to work here. Okay. Okay, first derivative. You can choose to put this information all together however you want, but I am going to do some number lines. So this is my first derivative number line. As I look at option 1 here, I see that there is first derivative information at -1 and 3. So I'm going to put -1 and 3 on my number line. And I'm going to look and consider what is my first derivative doing in each of these sections. So from first derivative is greater than 0 from -infinity to -1 and 3 to infinity. So what does that mean my graph is going to be doing in those 2 sections? It's going to be increasing, yes? And then we also know that the first derivative is less than 0 from -1 to 3. So that means it's negative, it's decreasing. Okay. So that's the information I know based on first derivative. Now, we're provided some second derivative information, right? As I look at second derivative, what information do they give me? They give me information starting, I'm going to try and match this up a little bit. -3, -1, and 3. My sections didn't end up quite equal because I'm trying to keep like my -1s lined up, my 3s lined up. I didn't anticipate the negative. I forgot about the -3 over there. Not that you have to. Okay? Just think it might be helpful. Okay, so what do we know here? Second derivative is positive, -infinity to -3, and -1 to 3. Positive means my graph is going to be concave up in those sections, right? Then, second derivative is less than 0. So negative from -3 and -1, 3 to infinity. So those pieces are concave down. Or if you prefer to do a CU-CD thing. Whatever, however you want to abbreviate to get this information together. And, okay, 3. The limit as x approaches -infinity of the function is -4. And the limit as x approaches positive infinity of g of x is +4. What are they giving me here?
Horizontal asymptote.
Yep.
Or vertical.
Nope.
Oh, horizontal.
These are horizontal asymptotes.
Oh, wait, no, yeah.
But they don't, basically, I don't know, I guess you could probably draw them all the way across. I know I had mine drawn all the way across. She did not draw hers all the way across. Basically, the idea here, and I think it does help, so if I go down to -4, as x approaches -infinity, my graph is going to run alongside -4. So as my graph goes off to the left, my graph is going to run along this asymptote. As x approaches positive infinity, so as my graph goes off to the right, we're going to run along +4 asymptote. And so you could draw your asymptotes all the way across. The advantage of not, though, is that this is kind of saying, okay, this is my left side, this is my right side. Okay? Okay. Anything else? I think we've got to go with it now, guys. That's all the information we got. They didn't give us any points, did they?
No.
I like it when they give us a point, but they didn't. So, well, take that back. We know a little bit of points here. What do we know based off of our first derivative?
Yeah, the max -1.
Okay. If we increase to -1 and decrease away from it, that's a max. And at 3, a min. If you decrease to 3 and you increase away from it, that's a min. What are these points in the second derivative? If the concavity is changing, these are point of inflection. I so prefer my IP. I don't know. Point of inflection, I don't like it, but okay. So, I guess you know what I should do before I start drawing? Need some values on here. We're going to have to at least go out to 3 here, aren't we? And we're going to have to at least go out to -3. Okay. So I know one thing when I've done this, you can do it how you want, but there's going to be a max above -1. I don't know where. I don't know how high. But what I tend to do is put a point on there to remind me there's going to be a max. There's going to be a min below 3. Well, let me rephrase that. technically, I don't even know if these are, they could be, this doesn't even have to go below the x-axis necessarily, but, okay. I think I'm ready to do it. So I'm going to start off increasing, right? So I'm going to start off low, and I'm going to be building up to -1. What am I doing in concavity as I get there? I'm going to start off concave up, but then somewhere around -3, I have to change to concave down. Can you visualize what your graph is doing there? My graph is, so if I'm, and as I come from the left, I'm coming from this horizontal asymptote, right?
Does it go like that?
Mm-hmm. At least I think so. So I'm going to, and the idea is, and this does not have to be, my point of inflection is not necessarily on the x-axis, but there's a point of inflection where it changes from concave up to concave down. And then at -1, I'm hitting a max. Okay? So that means after I pass through -1, now I have to start going down, right? So from -1 to 3, I'm going down. What kind of concavity am I doing? It's concave up. So if it's concave up, something like that. In other words, this point at -1 ends up being a hard point or a cusp or a sharp point.
So it doesn't really have to flow.
No, not necessarily. And when you've got concavity changing the way it did there, from concave down to concave up at a max, it can't really flow. Not like what you want it to. And then what are we doing after 3? We're increasing in a concave down form. So, and we're going to run alongside this, something like that. That is something like what my notes looks like. It does. These graphs do not necessarily flow very well. It all depends on, because right now it was more testing the skills here, putting it all together. Okay. Top of the next page. You saw these in last lesson, didn't you? Last lesson, 2 lessons ago. She just put in the sign chart kind of with all the information about it and how it all connects. You guys have seen me using those symbols, so you're used to them by now. So let's look at example 3 there. Woo, not that big. Okay. Can you sketch a possible graph given f prime? This is the hard part about this lesson. It's changing every problem. Sometimes you're given f prime, sometimes you're given f, sometimes you're given the second derivative. Every single time it changes. So with that in mind, I'm going to make a number line, whoops, for f prime. They did not label these pieces, did they? This must be the one. I'm going to call this point A and point B, if you will. Okay? What do you know if this is the derivative graph? What do you know about the derivative to the left of A? It is what? It's up above, so it is positive. What do you know about the derivative between A and B? It's below the x-axis, so it is negative. And the derivative to the right of B is above the x-axis, so it is positive. Now, that's my derivative information, yes? What's that say about the actual graph, f itself? If the derivative is positive, the graph itself is going to be increasing. If the derivative is negative, the graph is going to be decreasing and then increasing. So we know my original graph has to increase, decrease, increase. Now, second derivative. So second derivative is the derivative of first derivative. So when we're looking at a first derivative graph, what is the derivative of this graph doing? The derivative of this graph is first doing what? Decreasing, right? So it's first decreasing. And then the derivative of this graph is what? Increasing. And where did that derivative change? At 0. What does a second negative derivative mean? Concave down, concave up. So when we actually go to graph F, we know it's going to be concave down and then concave up. Okay.
Can you walk over with me? Yeah, right here.
Okay, so this second derivative is the first derivative of this graph. So what's the derivative of this graph doing? We have a negative derivative here because the slope. See it? Yeah, slope. That's what I should have said to begin with, huh? Okay, so now look at what we're doing. My graph is going to increase up to A, and at A there's going to be a max, at min a B, and at 0 a point of inflection. Yes? So I'm going to increase up to some point above A. I'm going to decrease down to some point below B, and I'm going to increase back up. Notice right there, my point of inflection. Now think about it. My first derivative was a quadratic. Notice the original graph is a cubic looking thing. Okay. Oh, I have a couple minutes. They're loud in the hallway today. Okay. I have a couple minutes so we can fill in these blanks real quick. Did we kind of get that? You're going to have to work hard here. I know I have to work hard to keep this all straight. Zeros of the derivative may be blank of the original function. What did these zeros turn out to be? Extrema. Mins or maxes. I'm going to write extrema. Extrema of the derivative are possible blank for the function. So what was my extrema of the original derivative graph? It turned out to be a point of inflection. And notice it's a possible point of inflection. You're not guaranteed that every time, right? All depends on what's going around it. When the derivative is above the x-axis, then what's the graph doing? So when this derivative was above the x-axis, my graph was increasing. Because when they say above the x-axis, we're basically saying positive, right? So what about when the derivative is below the x-axis? What's my original graph doing? Decreasing. If the first derivative is increasing, then the second derivative is concave up. Or excuse me, then the second derivative is greater than 0. I'm supposed to fill in, so f of x is concave up. And guess what the next one is? Concave down. Sorry, I am accustomed, when my brain sees second derivative greater than 0, I don't even think second derivative greater than 0, I think concave up. Okay, guys. We have lots of hard work to do tomorrow. Ooh, a lot.
We can do it.
I'm going to have to pick and choose.
Oh, crap.